Okay, now let's consider another example, which is to calculate solubility of magnesium hydroxide. Well, this example seems quite simple, but it is intriguing indeed. Okay, let's go on. So let's write pertinent equations. Okay, when this magnesium hydroxide is in water, it undergoes dissolution. Okay, to magnesium ion and hydroxide ion. Okay, the Ksp value for this one is written this way, and it is quite small. Another pertinent equation is the reaction between magnesium ion and hydroxide, okay, to give rise to magnesium monohydroxide, okay. And then the equilibrium constant K1 is given by this equation, and it is quite a large value, okay, 3.8 times 10 to 2. All right, so we cannot ignore the second equation. And as a default, we all the time we write this water auto dissociation. Okay, Kw is all the time is 10 to minus 14. Okay, and we write the charge balance equation here. The positively charged species are three: magnesium ion and magnesium monohydroxide and proton. Okay, and there is only one hydroxide ion. Okay, here. Okay, this is a charge balance equation. And also, let's try to write mass balance equation. Okay, okay. From we start from this first equation. Okay, so total magnesium the concentration of species that contains the magnesium ion is equal to the concentration of the species that contain hydroxide ion. Okay, on the left side we write species containing hydroxide ion, which is hydroxide ion itself and magnesium monohydroxide. Okay, it contains hydroxide. Yeah, and on the right side we write okay, we write the species containing magnesium ion, yeah, and which is magnesium ion itself and magnesium monohydroxide, and we have to multiply by 2 because on this first equation we know the the hydroxide ion concentration is 2 times larger than magnesium ion. Okay, here this one uh, is twice of this total magnesium containing species, and here this is very intriguing part, and you have to add this proton concentration. Why? Right? Why do we have to add this proton concentration? Yeah, here is the tip. This one, I wrote a comment, okay, on the mass balance equation. Yeah, again, we write this mass balance equation, and we added on the right hand side the proton concentration. Why? Why do we need this proton concentration? Okay, well, the origin of hydroxide ion here on the left side is two. One is magnesium hydroxide and also water. Okay, water auto dissociation also contributes hydroxide ion. Okay, but the hydroxide ion from magnesium hydroxide and water, they are not distinguishable. Okay, hydroxide ion is the same all the time, same. So to compensate hydroxide ion from water, you know, the proton concentration from water dissociation must be added, okay, since the same amount of protons and hydroxide ion is produced. Okay, here this water dissociation, yeah, we know the proton and hydroxide ion this concentration is the same. Okay, that's why you have to add on the right hand side the proton, this concentration. Okay, and now let's count how many unknowns and how many equations are there. Okay, what are the unknowns here? Okay, unknown are magnesium ion concentration and magnesium monohydroxide and proton and hydroxide ion concentrations. Okay, no more than that. Okay, so how many unknowns? 1, 2, 3, 4 unknowns. Yeah, but how many equations? There must be 4 equations. Okay, let's count the number of equations. 1, 2, 3, 4, and 5. Okay, more equations are there. Okay, and what's wrong? What's wrong? Okay, let's rearrange. Okay, this mass balance equation, and then you will end up getting this equation. Okay, this is a rearrangement of this mass balance equation, and then this equation is the same as charge balance equation. Okay, so actually there are only 1, 2, 3, 4 equations. Okay, and 4 unknowns. So when you solve the problem, sometimes you meet the mass balance equation is the same as charge balance equation. Um, they are not independent. Okay, so simply ignore one. Okay, so now we are ready to solve this problem. All right, here, since uh, the solution is basic, okay, because the magnesium hydroxide gives rise to hydroxide ion species. So in solution, the concentration of hydroxide ion is much greater than proton. So we make assumption like this. Yeah. Here it becomes, we ignore, yeah, this one, proton ion concentration, and it this equation is simplified like this. Okay, and using equilibrium constant, okay, we rewrite this one. Okay, using K1 instead of magnesium monohydroxide, we can use we can write in terms of magnesium and hydroxide ion concentration. Okay, here this magnesium ion concentration is given by this very simple equation, and applying this KSP into this one. Okay, and then KSP equation becomes eventually this way. Okay, okay, KSP is known. Okay, and K1 is also known, but this is seemingly quite a simple equation. It's not very simple to solve because it is cubic equation, not quadratic equation. Okay, cubic. Okay, so we have to solve by analytical solution is very complicated. Okay, I don't recommend uh, the general solution for this cubic equation, but I strongly recommend to solve this quadratic equation using a function called goal-seek in Excel. As an independent lecture, I gave a lecture how to solve this equation, yeah, by goal-seek in Excel. Okay, you may refer to that lecture. Okay, here I very the briefly I will explain. Okay, here you need first you need a guess of uh, this hydroxide ion concentration. Okay, you can start from 0.0001. Okay, because the hydroxide ion concentration may be low. Okay, so you make a reasonable guess, and then here using you write the on this cell, Excel cell, you write this equation and then calculate. You run goal-seek, and goal-seek um, is running by changing this guess. Okay, until um, this uh, the this value from this equation the same as this KSP. Okay, here. Okay, and then it will stop. Okay, final solution is that this one. Okay, this is a true solution. Okay, and then using KSP uh, or other equations, you can calculate this magnesium hydroxide concentration and also magnesium monohydroxide concentration. Okay, So Goal-Seek is a very powerful um, tool for obtaining the solution. Okay, this is what the, this is captured picture from Excel. All right. Okay, this is end of chapter 7. So I will give you the problems. Okay, this is a selected problems you solve, and then you upload your answers into the eCampus. Okay.